Welcome. At this point you should have this handout on my screen here. This shows us all of the vocab that is new that's going to be covered as it relates to evolution. You'll be using this in future activities that we do in class, so make sure that these terms have an understanding by the time you have wrapped up this discussion. If that means that you take notes off to the side here, by all means feel free. Do what you need to do so that you are prepared to use these words shortly. As we proceed through this video, you'll notice that there are questions that pop up that you need to answer. For example, this one right here, how can we use fossils to support evolution? You will not see any words on my screen that directly answer that question. You'll have to engage in listening to my explanation to formulate your own response to these questions. If any of them are not clear to you, you can go back and revisit some of the video, you can rewind, or you can write down a question off to the side and bring it to my attention so that you and I can hash it out. So we're going to look at early ideas about evolution. We're going to look at many different contributing people that helped us start to understand how life can change over a period of time, which is the definition of evolution. We're going to start by looking at this fossil right here, which is known as Eryops. As we see when we look at Eryops, we see that it resembles some things that are alive on our planet today, namely crocodiles and alligators. We can see that it's low to the ground, long body, tail, jaw with some teeth, and we can compare. That's essentially how we use fossils to compare. We look at how life used to look like, and we compare it to what current life looks like. So fossils, they serve as a way to show that there may be relations between today's living specimens and yesterday's extinct specimens, as we see here with Eryops. This guy went extinct, I think it was about 70 million years ago that this guy was wiped off the face of our planet. So he's been gone for a long, long time, but we have living things today that resemble him. Please don't take this to mean that Eryops changed into this crocodile. They may be completely unrelated. All we're doing when we're looking at fossils is really saying, okay, this is not on our planet anymore, but we do have living things on our planet that resemble it. Could there be a relation? So we're kind of looking at that question, could there be, not saying for a fact that there is. Our planet has about 2 million different living species that we know of. That's quite a large diversity of organisms. Certainly, in terms of evolution, some of today's species were not alive back many, many years ago. For example, humans have not always been on our planet. The oldest fossils of humans, or pre-humans I should say, that we have found arose about 300,000 years ago. So we haven't found any human fossils or human-related fossils beyond that point in history. So we could simply overturn that if we found a fossil from, say, the dinosaur era, but we haven't yet. So that's kind of why we're saying that humans did not exist during the dinosaur period. We haven't found no fossils to actually support that we did. We have found fossils, once again, that support that we have been around for 300,000 years. So this indicates that we came from somewhere. Where did we come from exactly? One of the popular beliefs, and I say that as a belief, not a fact, is that we came from monkeys, and actually current evidence suggests that we did not actually come from monkeys. However, humans and monkeys have an ancestor that we share in common. So humans and monkeys would be an example of an answer to this question. Can you think of two species that are quite similar? Well, humans and monkeys, yeah, they kind of are. We have 5 toes, or an arm, 2 arms and 2 legs. We can walk upright. Similar diet, mammals, hair patterns, the way that we take care of our young after they're born, and frankly the pregnancy process. Very, very similar. So we probably do have a common ancestor with monkeys. Now, what is that common ancestor? Frankly, we have no idea. And that common ancestor would not be found living on our planet today. So we have essentially evolved along with monkeys into 2 different species. What I'd like you to do on your paper is think of a few other species that are similar yet different. Maybe it's tigers and lions. They're similar, but they're quite different. Once you have put down a couple species on your paper that are similar yet different, why may have those 2 living things evolved away from each other? If they were the same species and then they changed, what may have caused that? That's something that we're going to be talking about, and I'd like to think about and formulate your thought on your paper. Doesn't necessarily have to be correct. I'd just like to see what you're thinking. At this point, I'd like you to think about the word evolution, and on your paper, write down your personal definition of it. Please don't run out to Google and look up the word. I'd like to see what you're thinking of. I want to see your thoughts on evolution at this point. So come up with evolution, define it in your own words. Turn the page in your notes. You'll see this slide at the very top underneath the letter C. We're going to start looking at evolution and how we started to become aware of it from this point in our discussion moving forward. And it kind of centers around a famous person that you probably have heard of, Charles Darwin. He proposed his theory of natural selection in the 1800s. Natural selection is sometimes called survival of the fittest, meaning that organisms that have phenotypes best suited to survive in their environment will probably have a better chance at staying alive for a longer period of time and then having more children because they're staying alive for a longer period of time than, say, for individuals that have phenotypes that don't really mix so well with the particular environment. He is not the father of evolution. Evolution had actually been discussed way before Darwin's time. And we're going to look at some of those people. Here's a list of the names of the people that we're going to be looking at, starting with Carolus Linnaeus, Buffon, Erasmus Darwin, Lamarck, Hutton, and Lyell. So let's check out what these guys helped us kind of understand. We're going to start with Linnaeus. We'll be talking more about Linnaeus in the future here, but I want to start with just identifying that he came up with a naming system for living things, and essentially all living things are named based on his system today. Our name, based on the Linnaean system, is Homo sapien. You've heard that before. We have a first name Homo, we have a last name sapien. Every single living thing has a first and a last name based on this system. Now, when we look at the naming system, we can actually show relation using the first name. So we have Homo sapien, we're Homo sapiens. Other living things that would be related to us would be like Homo neanderthalis, which would be the Neanderthals. They're no longer around today. That's a primitive human being, but it does kind of illustrate that we have a relation with them based on the same first name, Homo. So how would this be beneficial to evolutionary scientists? Well, it kind of shows that there's common descent, meaning that living things descended from living things that came before them. So we came from Homo neanderthalis. Homo neanderthalis came from another primitive human being, Homo erectus, so on and so forth. So it does show our lineage, shows our relationships, and it shows kind of where we came from. The next guy on our list was Buffon. He came way earlier than Charles Darwin. He was from the 1700s. And what we need to understand before looking at Buffon is that the popular belief amongst humans in his day was that everything that was alive was kind of put on our planet at the exact same time, and the things on our planet that were alive in his time frame were the things that just didn't go extinct. Which would mean that essentially we were on the planet at the same time dinosaurs were as well, which to our understanding is not true at all. So he kind of changed the thinking a little bit by saying, hey, you know what? Maybe we were not on the planet at the same time Neanderthals were. Maybe we do have a common ancestor, though, that changed over the course of time and evolved into what we now know are modern humans. So he proposed that species had ancestors that they were descended from, and not that we all were put on a planet at the exact same moment. He used evidence of life on Earth similar to what we were looking at with the fossils, with Eryops and crocodiles. Eryops is not on our planet, but things that very much resemble it today are. So what is the evidence to support this? Well, we have the fossil record. We can see that in those fossils, they're extinct. They're not on our planet now, but things that resemble those species are on our planet. And frankly, if we were on the planet at the same time as the dinosaurs, well then how come we're not finding human fossils? It doesn't seem to add up. Same era, 1700s, Erasmus Darwin. This is Charles Darwin's grandfather. He kind of built off of the thought of Buffon, saying that living things have an ancestor that they were descended from by tying all living things together, saying that all living things came from one single common ancestor. Most likely, this common ancestor would have been a single-celled organism that soon gave way to all the different living things that we have on our planet now, and in the past that have since gone extinct. Which kind of leads us to think that why would anyone believe that humans came from a single-celled organism billions of years ago? Well, there's a few things that we can consider. First off, looking at DNA. We talked about DNA previously, and all living things have the same DNA. There's the A, T, C, and G. It doesn't matter what you look at, they all have the same thing. We also looked at amino acids, and a lot of living things share the same exact amino acids. I mean, when we compare the DNA sequence of humans to chimpanzees, there's a 99.9% overlap. Like, it's the exact same thing. We can even extend that and compare the human DNA to sequoia trees, which are really big, tall trees. Our DNA is 25% the same as theirs. So it's kind of hard to think that we have DNA that's 25% the exact same thing as a tree and not be related. So it does kind of tie in that we do have a relative really, really long time ago with trees. And we'll talk about some of the evolutionary processes that may have caused life to become very different, because as you well know, we are really, really, really different than a tree. This will conclude part one of our discussion. When we return, we're going to pick up by talking about Lamarck.